Hey everyone, today I will talk about a brief explanation of KNN algorithm. Mainly we will talk about how does it works, how do we optimize it, and how does it behaves when we pass the data and parameter when create the object. First of all, um, what is KNN? KNN stands for K nearest neighbor. So it's an algorithm that is focusing predict value of X in the K number of its nearest neighbor. The example is, let's say there are 5 nearest neighbor of the value of X. The data points near the X value, the 5 nearest neighbor data points are green, 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 and red. So that those are the nearest from X. So how do we classify X? This is the classification model cases. So we will determine by its majority of voting based on its nearest neighbor. So we can say that because the mode of this data is green, so we can say that X could be classified as green. Because that's how it works of the KNN. The basic idea of KNN is it's a lazy learning method. So it doesn't really doing training at all. It only stores the data on the class, and the computation that being made is on testing pace when we're doing the prediction. Because of that, the training time has no cost on the memory. So it's not slow at all. So it's not taking anything on the memory usage or CPU usage. But when we're doing the predict of the value, it will be expensive as hell. Due to if you're making a prediction, KNN will just do all computation again and again. So it's not saving any model. So we're going to do the calculation forever when we're doing a predict. So the algorithm is simple. It's pretty simple. So it's just measure the distance between X and the nearest data point and choosing the nearest one. Usually we're using Euclidean distance or Manhattan if we have, you know, the high dimensionality data, but basically we're not really into it. I mean, the high dimensional data. So mostly the common use is the Euclidean. So basically it's just calculate using difference between the X and its data points, training data points. So we calculate one by one and we square root it. So it's not going to be negative. And yeah, that's how we were going to do. So the difference between Euclidean and Manhattan is more like a triangle. You can see this triangle right here. For Euclidean, you're just going to A to C and it's straightforward. For Manhattan, you need to go to A to B to C, and it takes a lot of time. And yeah, that's the difference between Euclidean and Manhattan. If you wonder why we choose one another, after we calculate the distance of each data point to the X value, we will find the nearest one according to the K. If K is equal to 1, then we will get a data of 1 nearest data point. So the neighbor is just 1 data point. If the K is 5, then we have 5 neighbors. So after we get the data points, the nearest data points, for regression model, we will get the mean of the data. But if it's classification, we will return the mode or majority class of that 5 data points, like what we did in the green case above, that it will get the value as classified as a green value. Let's talk about optimization. Fun fact that Here's the thing. KNN doesn't have any cost function exist because it doesn't really train the data. It doesn't really have the training model. It calculates everything on predict pace. So it doesn't have any cost function. And that's a good thing because we don't have to, other than we're passing the neighbor's value, we don't have to worry about anything else. So if that's the case, how do we optimize the model then? There's several choices to optimize the model performance. We can choose the best K value. Like we don't have to use 5 forever, right? Because it's too small, it might lead to the high variance data. So we can also choosing the right distance measurement. So you don't have to stick to Euclidean distance. You can try to use Manhattan if you want, really want it. But the most common one is Euclidean. But yeah, you can. This is why we try to optimize the model, right? You can doing the feature scaling as well for better estimation because we already normalized the value, so it will affect the model performance for sure. So let's talk about how to choose the best K value. K value is basically the count of the neighbors around the X. So if the K value is equal to 5, we will get the result from 5 nearest neighbors of X. If 10, then 10. If 100, then 100. And the smaller the K, the complex the model will be. Just remember that. Aim for higher K. So you will never getting overfitting data, overfitting model. Aim for higher K. Remember that there are no optimum K value ever. You need to find it. You need to do some repetitive stuff like doing looping in range. Like you can try for looping 1 to 100, for example, and choose the best result. So choose the K equal to the I, initialize in your KNN model, predict using that model, get the result, repeat doing until satisfy, getting until K100. After all, compare. Usually I'm using plotting here, like we will do in the next couple minutes. But yeah, you can try to visualize the result. It will help you analyze later. Let's talk about model construction now. We'll talk about how the models build it, how does it work, what is the pseudocode, and how to implement a real model from scratch. How the algorithm works. We already talked a couple of times already in above discussion. So we choose the K value. We calculate the distance between X and the data points, the training data points, sort the value from the nearest one, get the measuring vote of the nearest data point, the K nearest data point. If we have 5, then getting 5 nearest data point. Output the class or classify it, right? The pseudocode is pretty much simple. I'm just explaining what I do here in the code review. So we define the training data, find the K, calculate the distance, sort the distance, and select the nearest data point and get a result. That's what we're going to do. This is the prediction pseudocode, just the import this data model right here that we already trained and get the input, doing the prediction. It will automatically output based on the thing that we already defined for. So that's the pseudocode. It's pretty simple, so it's not that hard. Now we're going to build the algorithm using Python. So we just need the K neighbor, X and Y, meaning X is the features, Y is the target data, target function, or dependent variable. This is independent variable. Y is dependent variable because it depends on X. When initialize KNN, we will passing the K neighbors. We want to know how many neighbors around the data points. And for predicted value, we just, calculate the distance here and sort and return the nearest neighbor. And for the prediction, we will going to use statistic mode, meaning we get a majority value. So I already summarized it here, create a KNN object, a split function to insert X and Y, has predict function, the model using Euclidean distance, after find the distance, sort it, and returning the list of sorted distance, slice it to the K neighbor value, meaning that it will return 5 data if the K neighbors has 5. So you can use this model for prediction. So basically it's just import the data, separate the independent variable and dependent variables, put in several variables, declare the input, generate the model, fit the model using these 2 data, and do the prediction there. But how do we know the best K neighbors value to fill our model? We already talked about it, that you need to do the looping, right? So by randomly choosing the K neighbors value is not helping. You need a graph. You need to understand how your prediction value act when you pass the K neighbors. So what I do right here is I'm looping range 1 to 100 and use the K of each iteration. So 1, 2, 3, 4, 5, 6 until 100 as a K and doing prediction with that model. So afterwards, I already get the prediction right here. I append both value as X and Y and doing plotting right here. So you can see that this is the result. In K around 19 or 18, the prediction is not stable at all. From here to there, from 19 to 50 probably, prediction is not stable. It is high variance. A little small change going to affect the model at all. After K is greater than 50, meaning 60 or 80 or 100, it become more stable and stable. So, which is why when it aim for a higher K. By the way, the predict result is the correct data is 0. So yeah, you need to understand that aim for higher K is better. So yeah, we can see the code right here. I already putting it. So we can just see that there's a lot of data here. Yeah, already doing a lot of things. And yeah, basically that's it, everyone. And I put some references here. I read some paper and doing some research on the YouTube channel of StartQuest and also a couple of articles that I'm reading. So yeah, thanks everyone. I think that's all I'm gonna say. Thank you. Bye bye.